Welcome back to Cosmos in a Pod's Space and Astronomy series.
Hmm.
Today, we're going back to basics, the very beginning. Imagine our solar system not as this like neatly arranged, collection of planets and moons, but as a chaotic, swirling cloud of gas and dust. That's where we're starting our deep dive today, unpacking how that primordial chaos eventually gave rise to the solar system we call home.
Yeah, it's truly mind-boggling to think about, isn't it? That everything we see in our solar system today, from the sun to the smallest asteroid, originated from this single massive cloud.
Absolutely. It's like trying to imagine baking a cake from a giant bag of flour and sugar floating in space.
Yeah.
Where do we even begin to understand this process?
Well, our story starts roughly 4.6 billion years ago, with that massive cloud you mentioned, which astronomers call a solar nebula. Picture it as a vast, swirling disk of gas and dust, many times larger than our entire solar system today.
Okay, so we've got this giant cloud of ingredients. What happens next? How do we go from this nebula to, well, everything?
Gravity is the master chef here. As the nebula collapses under its own weight, it starts to spin faster and faster, like a figure skater pulling in their arms. And as it spins, most of the material gets pulled towards the center, forming a dense, hot core.
So gravity is basically squishing everything together at the center.
Exactly. And the temperature and pressure at that core becomes so intense, reaching millions of degrees, that something incredible happens. Nuclear fusion.
Uh-huh. The birth of a star. Our very own sun.
Precisely. Hydrogen atoms, the most abundant element in the universe, are forced together under such extreme pressure that they fuse, releasing a tremendous amount of energy. And that, my friend, is how a star is born.
Okay, so we've got our star, the sun, blazing away at the center of the solar system. But what about all that leftover gas and dust? How does that transform into planets and moons?
Now we enter the realm of planetary formation, a fascinating interplay of temperature, gravity, and time. Let's start close to the sun, where temperatures were and still are incredibly high.
So we're talking about the inner solar system,
Yeah.
the realm of Mercury, Venus, Earth, and Mars.
You got it. In this intense heat close to the newborn sun, only heavier elements like rock and metal could withstand the temperatures and condense into solid particles. Lighter elements like gases and ices just couldn't hold on in that heat. They remained vaporized.
So it's like a cosmic sorting machine. The heavy stuff stays close to the sun, and the lighter stuff gets pushed further out.
That's a great way to think about it. And this is a key concept in understanding why the inner planets, the terrestrial planets, are relatively small and rocky. They formed from the heavier materials that could condense in the intense heat near the sun.
All right, so the inner planets are the tough guys of the solar system, built to withstand the heat. But what about the outer solar system? Things must cool down out there, right?
Exactly. As you move further from the sun, the temperature drops significantly. We reach a point called the frost line, a critical boundary in the solar system's evolution.
Okay, frost line, tell me more about that. What makes it so important?
Beyond the frost line, the temperature becomes cold enough for lighter materials like water, ice, methane, and ammonia to freeze and condense into solid particles. This dramatically expands the inventory of planet-building materials.
So it's not just rock and metal anymore. We've got ice in the mix now.
Precisely.
Right.
And this is where the gas giants come in. Jupiter, Saturn, Uranus, and Neptune. These behemoths formed beyond the frost line, where they had access to a much larger pool of materials, including all those ices.
Right, but hold on. The gas giants are much larger than the inner rocky planets. How do they get so big if they're made of lighter materials?
It all comes down to gravity again. These
Yeah.
gas giants likely started with rocky cores similar in size to the inner planets. But being beyond the frost line, they were surrounded by a vast sea of ice and gas.
So their gravity went into overdrive, pulling in all that extra material.
Exactly. They became like giant vacuum cleaners, gobbling up vast quantities of hydrogen and helium, becoming the massive planets we see today.
So we've got the inner rocky planets and the outer massive gas giants, all shaped by the temperature gradient in the early solar system. But what about all the other stuff? The asteroids, the comets, where do they fit into this picture?
Those are the leftovers, the bits and pieces that didn't quite make it into planets. Not all the material in the solar nebula ended up forming these large celestial bodies. Some of it clumped together into smaller objects, forming the asteroid belt between Mars and Jupiter and the icy Kuiper belt out beyond Neptune.
So asteroids are basically rocky crumbs and comets are icy leftovers.
That's a great analogy. Asteroids are mostly rock and metal remnants from the inner solar system. Comets, on the other hand, are more icy hailing from the colder outer reaches.
It's amazing to think that we have these remnants of the early solar system still floating around out there. But I have a feeling this early solar system was a pretty wild place, right? We're not done with the chaos yet, are we?
You're right about that. The early solar system was far from peaceful. Imagine a cosmic billiards game. With planets, asteroids, and comets constantly colliding and jostling for position, this period of intense bombardment, aptly named the Late Heavy Bombardment, had a profound impact on the solar system's evolution, shaping the surfaces of planets and moons, and even influencing the very architecture of our planetary system.
Okay, late heavy bombardment. Paint me a picture. What kind of mayhem are we talking about?
Imagine a barrage of asteroids and comets, some the size of small planets, hurtling through the solar system, colliding with planets and moons. It was a chaotic and destructive time. But it also played a crucial role in shaping the solar system we see today.
So it's like a cosmic demolition and renovation project all rolled into one.
Exactly. For instance, take a look at the moon. All those craters, those pockmarks on its surface, are scars from this period of intense bombardment. Earth would have experienced similar bombardment, but our planet's active geology has erased most of the evidence.
So the moon is basically a time capsule, preserving the history of this violent period.
Precisely. And it's not just about craters. The late heavy bombardment likely had even more dramatic consequences.
Intrigued. Give me an example. What else could have happened during this chaotic time?
Well, consider the Earth-Moon connection. The leading theory for the moon's formation involves a cataclysmic collision between the early Earth and a Mars-sized object, which we call Theia. This impact, likely occurring during the late heavy bombardment, would have been colossal, ejecting a massive amount of debris into space.
So the moon is basically a giant chunk of Earth that got blasted off during a cosmic collision. That's incredible.
It is a dramatic story, and the implications are profound. This impact not only gave us the moon, but also likely played a role in stabilizing Earth's rotation and creating the conditions that would eventually allow life to flourish.
Okay, the Earth-Moon connection is pretty mind-blowing. But I'm also thinking about those giant planets, Jupiter and Saturn, cruising around the solar system during this time. What role did they play in all this chaos?
Yeah. Yes, the gas giants. Their story during this period is fascinating. They weren't just sitting still, they were migrating, shifting their orbits due to gravitational interactions with each other and the surrounding debris.
Hold on. Migrating planets. So Jupiter and Saturn were basically moving house during this time.
In a sense, yes. And their movements had a huge impact on the rest of the solar system. Jupiter, for example, likely migrated inward towards the sun and then back out again, scattering objects in the asteroid belt and preventing a planet from forming there.
So Jupiter played a role in shaping the asteroid belt. That's amazing. And what about Saturn? How did its movements affect things?
Saturn's migration likely played a role in shaping the Kuiper belt, the distant realm of icy objects beyond Neptune. It's like a cosmic dance with the giant planets influencing the orbits of smaller objects, shaping the architecture of the solar system.
I'm starting to see how this period of chaos, this late heavy bombardment, wasn't just about destruction. It was also a time of creation and reshaping. But eventually things calmed down, right? How did our solar system transition from this chaotic state to the relatively peaceful, organized place we see today?
That's a great question. And it leads us to the next chapter in our solar system's story, a period of stabilization and the emergence of distinct regions within our planetary system.
Okay, I'm eager to hear how things settled down. Tell me, how did our solar system find some semblance of peace after all that chaos?
Well, over hundreds of millions of years, the solar system gradually calmed down. One of the key players in this process was the sun's solar wind, a constant stream of charged particles flowing outward from our star.
So the sun was cleaning things up, blowing away the leftover debris from the early solar system.
Exactly. This solar wind, like a cosmic broom, swept away much of the remaining gas and dust, clearing the space between the planets.
That makes sense. So with less debris flying around, collisions would have become less frequent, allowing things to settle down right.
Precisely. As the solar system stabilized, the planets settled into more stable orbits, and the distinct regions we see today began to emerge.
Okay, let's talk about those regions. What are the major divisions within our solar system?
Well, starting closest to the sun, we have the inner solar system, often called the terrestrial zone. This is the realm of the rocky planets, Mercury, Venus, Earth, and Mars. They're relatively small, dense, and composed primarily of rock and metal. And of course, you can't forget the asteroid belt, a collection of rocky remnants between Mars and Jupiter.
Right, we talked about how Jupiter's migration might have prevented a planet from forming in that region. So the inner solar system is all about rocky worlds and the remnants of planet formation that never quite happened. What about further out?
Moving outward, we enter the domain of the gas giants, the Jovian zone. This is where Jupiter, Saturn, Uranus, and Neptune reign supreme. These massive planets, composed primarily of hydrogen and helium, are truly giants compared to the inner planets, and they each have their own unique features and retinues of moons.
Yeah, those gas giants are incredible. I've always been fascinated by their rings and moons. It's like each one is its own mini solar system. But what lies beyond the gas giants? What's at the edge of our solar system?
That's where things get really mysterious and intriguing. Beyond the gas giants, we have the outer regions, which include the Kuiper Belt and the even more distant and mysterious Oort cloud.
The Kuiper Belt, that's where Pluto hangs out, right? It's like a cosmic demotion from planet to Kuiper Belt object.
Well, Pluto's reclassification sparked quite a debate. But yes, the Kuiper Belt is home to Pluto and a vast collection of other icy objects, remnants from the early solar system. It's like a frozen reservoir preserving clues to the conditions that existed billions of years ago.
And the Oort cloud, what's that all about?
The Oort cloud is even further out, a vast spherical shell of icy objects thought to surround the entire solar system. It's so far away that we haven't directly observed it yet. But it's believed to be the source of long-period comets that occasionally grace our skies, like cosmic messengers from the solar system's outer limits.
Wow, a giant icy shell surrounding the entire solar system. That's an incredible thought. Okay, so we've got these distinct regions, inner rocky planets, outer gas giants, and the icy realms beyond. But we haven't talked much about moons. They seem to play a pretty big role in the solar system story too, right?
Absolutely. Moons aren't just passive bystanders. They're dynamic worlds with their own fascinating stories. And they play a crucial role in shaping the evolution of their host planets.
Okay, I'm all ears. Tell me about some of the most intriguing moons out there. What kind of roles do they play?
Well, for starters, let's consider Jupiter's moons, particularly Europa and Ganymede. They're both thought to harbor vast oceans of liquid water beneath their icy surfaces, potentially even more water than all the oceans on Earth combined.
Hold on. Oceans of liquid water, like potentially habitable oceans. That's mind-blowing.
It is, and it's one of the reasons why astrobiologists are so excited about these moons. They could potentially harbor life as we know it, or even life as we don't know it. Imagine that. Life in the oceans of a moon orbiting Jupiter.
That would completely change our understanding of life in the universe. Okay, so Jupiter's moons might have alien life swimming around. What about Saturn's rings? How did those incredible structures form?
The leading theory is that a moon, or perhaps several moons, got too close to Saturn and was torn apart by the planet's immense gravitational forces. The debris from this shattered moon then spread out into the rings we see today.
So Saturn's rings are basically a cosmic graveyard, the remnants of a moon that got too close to the planet.
Yeah.
That's both beautiful and a little bit morbid.
Exactly. It's a reminder that even in the seemingly stable solar system we see today, there are forces of destruction and creation at play, and those forces have shaped the incredible diversity of worlds we see in our planetary neighborhood.
Speaking of diversity, we've talked about planets and moons. But what about asteroids and comets? What roles do they play in the grand scheme of things?
Asteroids and comets are like cosmic time capsules preserving material from the very earliest days of our solar system.
So they're like little windows into the past.
Precisely. By studying them, we can learn about the conditions that existed when the solar system was forming. They provide clues to the composition of the solar nebula, the building blocks of planets, and even the potential delivery of water and organic molecules to the early Earth.
It's amazing to think that we have these little pieces of solar system history right here in our cosmic backyard. But I'm also thinking about the future. What's in store for our solar system billions of years from now? I have a feeling things won't stay peaceful and organized forever.
You are right about that. The solar system, like everything else in the universe, is subject to change. And those changes are driven by the evolution of our sun, the star at the heart of it all. As the sun continues to burn through its nuclear fuel, it will eventually enter a new phase of its life cycle, one that will have dramatic consequences for the planets orbiting it.
Okay, I'm ready for the next chapter in the solar system saga.
Yeah.
What does the future hold for our sun and its planetary family?
Well, in about 5 billion years or so, the sun will begin to run low on hydrogen, the fuel that powers its nuclear fusion.
So the sun has an expiration date. What happens when it starts to run out of fuel?
As the sun exhausts its hydrogen supply, it will begin to undergo a dramatic transformation. It will start to expand and cool, becoming what astronomers call a red giant star.
A red giant. How big are we talking?
Big enough to engulf Mercury and Venus, and possibly even Earth. It will be a truly spectacular sight, but not a very good day for any life that might still be clinging to those inner planets.
Wow, so the inner solar system basically gets swallowed up by the sun. What happens to the outer planets?
The outer planets will likely survive, but their orbits will be disrupted as the sun's gravitational pull weakens. The solar system's architecture will undergo a major reshuffling.
It's amazing to think about these vast timescales and the dramatic changes that are in store for our solar system. But what happens after the red giant phase? Does the sun just fizzle out?
Not quite. The sun will eventually shed its outer layers, leaving behind a dense hot core called a white dwarf. This white dwarf will slowly cool and fade over billions and billions of years, eventually becoming a cold, dark ember.
So the sun's story is a tale of fire and ice. From a blazing inferno to a frozen remnant, it's kind of poetic in a cosmic sort of way.
It is, and it reminds us that even the stars themselves have a lifespan, a beginning, a middle, and an end.
We've covered so much ground in this deep dive, from the chaotic beginnings of our solar system to the orderly arrangement we see today, and even a glimpse into its distant future. It's been an incredible journey.
It has. And I hope it sparked a sense of wonder and curiosity about our place in this vast and ever-evolving universe.
It definitely has. What stands out to me is the realization that our solar system isn't static. It's a dynamic, ever-changing system shaped by forces we're still trying to fully understand.
You've hit the nail on the head. The study of our solar system's evolution is an ongoing detective story. We're piecing together clues from meteorites, from observations of distant stars and planetary systems, and even from missions that are exploring the planets and moons right here in our own cosmic backyard.
And there's still so much we don't know. There are mysteries yet to be solved, questions that haven't even been asked.
That's what makes it so exciting. There's always something new to discover, new insights to gain. As we continue to explore the universe, we're constantly refining our understanding of how our solar system came to be and where it might be headed.
Speaking of exploration, what are some of the big questions that scientists are still trying to answer about our solar system?
Well, one of the big ones is how common are solar systems like ours? We've discovered thousands of exoplanets, planets orbiting other stars, but we're still trying to figure out if our solar system's architecture, with its rocky inner planets, gas giants, and icy outer regions, is typical, or if it's a cosmic oddball.
So we're still not sure if we're a one-of-a-kind solar system or if there are others out there like us.
That's right. And then there's the question of Jupiter's migration. We know it happened, but we're still trying to understand the details. How did it affect the formation of the other planets? Did it play a role in delivering water and organic molecules to Earth? The ingredients for life as we know it?
It's like a giant cosmic puzzle.
Yeah.
And we're still trying to figure out where all the pieces fit.
Exactly. And then there's the possibility of undiscovered planets lurking in the outer reaches of our solar system. Some astronomers believe there might be a so-called Planet 9, a large planet far beyond Neptune, influencing the orbits of other objects in the Kuiper Belt.
A hidden planet.
Mm-hmm.
Now that would be an incredible discovery.
It would, and it would highlight just how much we still have to learn about our own cosmic neighborhood.
This has been an incredible deep dive into the evolution of our solar system. We've gone from a chaotic cloud of gas and dust to the beautifully complex and dynamic system we see today, and we've even glimpsed into its distant future.
It's a story of creation, destruction, and renewal, a testament to the incredible power of gravity, temperature, and time.
And it's a story that's still unfolding. We're living in a cosmic wonder, and there's so much more to explore and discover.
If you're eager to continue your exploration of the cosmos, I encourage you to check out images from the James Webb Space Telescope and other incredible missions that are revealing the universe in unprecedented detail.
It's a great reminder that there's a whole universe out there waiting to be explored.
And if you want to keep diving deep into the wonders of space and astronomy, and don't forget to follow Cosmos in a Pod and subscribe to our YouTube channel, we'll continue to explore the mysteries of the universe together.
Thanks for joining us on this incredible journey through time and space. Until next time, keep looking up and never stop exploring.